Excellent. So at the end of that, after you added up all the areas we're subtracting, 28 minus 12 is 16 square units. Woo! That was a really great job for shape G. Let's move on to shape H. When I was looking at shape H, I made a rectangle and half of the circle. So when I'm looking at this rectangle, I notice that it's a 1, 2, 3, 4 by 1, 2, 3, 4, 5. A 4 by 5, that's right, 20 units. Now I need to look at this circle. It's half of the area of a circle with a radius of 2. Remember, what's the area of a circle? Well, the area of a circle is pi r squared, so we're going to have to take half of that. Our radius here is 2. Pi, 2 being squared, then divided by 2. Order of operations, we need to do the exponent first. So pi times 4 divided by 2. Well, what's 4 divided by 2? That's 2. So this is 2 pi. And we're using 3.14 as an approximation. So that means this is about 2 times 3.14. Using my calculator, I get about 6.28. So to find my total area of shape B, I added 20 and 6.28 to get a final area for shape H. Shape H is 26.28 square units. Awesome. Let's finish up our last 4 shapes. When I was looking at shape I have a rectangle that's a 3 by 2, which is 6. I have one of these triangles, which is the same as this triangle up here. Did you notice that? So they must have the same area. Do you remember what it's called when shapes are congruent? Sorry, oops, just told you. Do you remember what it's called when shapes have the same size and shape? That's right, they're called congruent. So this is a 1. And here I notice it's a 1 by 1. And that means this area is a half and this one is a half. And a half is 1. So we have 6 plus 1 plus 1, which you guessed it correctly. That shape has an area of 8 units squared. Cool, let's finish our last 3 shapes. Shape J, I broke into a trapezoid, a tall trapezoid, a rectangle, and a short trapezoid. So shape J, I looked at this height of the trapezoid as 1, 2, 3, this base as 1, and this base as 3. Area of a trapezoid is base 1 plus base 2 divided by 2 times my height. So taking a look at my larger trapezoid, I end up with 1 plus 3 divided by 2 times my height, which is also 3. 1 plus 3 is 4, following order of operations. 4 divided by 2 times 3. 4 divided by 2 is 2, and 2 times 3 is 6. So the area of this larger trapezoid is 6. The area of this short rectangle is a 3 by 1, which is 3. Now, taking a look at this smaller trapezoid, I have a base of 1, a base of 3, and a height or an altitude of 1. Base 1 plus base 2 divided by 2 times your height. That's nice, multiplying by 1. 3 plus 1 is 4. 4 divided by 2 is 2. We don't have to worry about multiplying by 1. So if we add 6 plus 3 plus 2, we get our final answer, which is 11 units squared. Cool. Let's take a look at K. When I was looking at shape K, I noticed I had another one of these tiny squares, which has an area of a half. Triangles. Tiny triangles has an area of a half because it's half of the square, which is an area of 1. And then this rectangle, which has an area of 4. Meaning that shape K has an area of, you guessed it, 4.5 square units. So 4.5 units squared. Let's take a look at our last shape L. Shape L is very interesting because it's called a tilted square. You're going to be looking at these squares a lot next year when we look at square roots and radicals. So taking a look, what I decided to do was take a large perfect square, which is a 3 by 3, an area of 9, and subtract these 4 little congruent triangles. Each one of these triangles has the same area because they're congruent, with a base of 1 and a height of 2. Remember, the area of a triangle is base times height divided by 2. So again, to find L, I'm going to take the area of the large square around it and subtract 4 of these little triangles that have a base of 1 and a height of 2. So we're going to have 9 minus base times height divided by 2, which is 2 times 1 divided by 2, which ends up just being 9 minus 1, which tells me L has an area. Oops, but there's 4 of those. There's 4 of those triangles. So we have to subtract 4, 9 minus 4, which that means this square has an area of 5 units squared. Awesome. Let's turn the page. Awesome. We're going to use those same ideas, except now we're not always going to have little squares with 1 centimeter in length. We're going to have different types of irregular shapes. So let's take a look. Using your knowledge from our first activity about area, we're going to find the area of the following irregular shapes, and we're going to organize our work and show our calculations. So I'm going to do shape 3 with you, and then we'll break up shape 1 and 2 together, and you can calculate those areas. So taking a look at shape 3, the first thing is we want to break these up into shapes that we know how to find the area. Well, if I cut or slice this arrow into a triangle and into a rectangle, let's see if I can figure out the area. I'm going to have the area of this rectangle plus the area of this triangle. So let's see, what do we need to know to find the area of a rectangle? I need to know the base and the height. So here in my picture, I already know that I have a base of 23.7 meters and a height of 32.4. So that will be pretty simple to find the area, 32.4 times 23.7. And I still need to find the area of my triangle. So when I'm finding the area of a triangle, we use, what's the formula for the area of a triangle? Oh, that's right, base times height divided by 2, or 1/2 times base times height. So if I'm taking a look at my arrow, my base goes all the way from here to here. Well, what is that length from here to here? Well, that's made up of 9.3, 23.7, and then 9.3 again. So we need to find the total by adding all of those numbers together. Grab your calculator. What do you get? That's right. We get 42.3. So we know that the base of our triangle is 42.3 meters. And it's always nice to redraw these shapes and fill in what I know. Now I need to know the height or the altitude of my triangle. Well, that's going to be from here to here. It looks like they gave us the dimensions of the entire height of this arrow. So let's see, from here to here is what I want to know. What could I do just to find this much? If I know the total, and then I know from here to here is 32.4. Oh, we can subtract. That's right. If we have 49.8 and we subtract 32.4, we'll have this missing height. Perfect. If you grab your calculators and do that, we end up with 17.4. So we know our height is 17.4. Let's plug that in. 42.3 is the base. The height is 17.4. I'm going to divide that by 2. It's nice to use parentheses here for multiplication because we have decimals and you might get a little bit confused if we use dots for multiplication. Okay, grabbing your calculators, when we multiply these two numbers, we get 767.88. Plus, first I'm going to multiply these two together with my calculator and then press equals and then divide by 2. And when I do that, I end up with 368.01. I'm going to add those together and I end up with 1,135 and 89 hundredths. And what's the units? Oh, square meters. Meters squared. And that is your answer for number 3. Perfect. Nice job, you guys. Okay, so let's think about how we're going to break up shapes 1 and 2, and then you'll start working on those with your groups. Shape 1, well, we could break this up into 2 rectangles, or what we could do is we could just find the area of the large square and subtract this little rectangle. That sounds pretty simple. Let's do that. I'm going to find the area of the entire big square, and then I'm just going to subtract the little rectangle. On number 2, notice we're only finding this kind of wing look. And let's break this into 2. What shapes are these? What shapes are these? They're 2, they have 4 sides, the opposite sides are parallel. Oh, that's right, these are 2 parallelograms. And this is telling me that this side is 30 centimeters and this side with these 2 congruent annotations. And they have bases of 30 centimeters and 30 centimeters and a height of 40 centimeters. So what do we know about these parallelograms? Oh, well, we know that they are 2 congruent ones. So all we have to do is find the area of one of the parallelograms and multiply it by 2. Awesome. Go ahead and finish 1 and 2 with your groups. I'm going to give you about 4 minutes to finish 1 and 2 with your groups. Please pause the video and then we'll go over our answers. Awesome. Let's see how we did. So when I found the area of the big square minus the little rectangle, I did 7.9 times 7.9 minus 3 times 4.5, and I end up with 62.41 minus 13.5, which is 48.91 square feet. So that's what you should have gotten for your answer. And on number 2, when I figured out that these were 2 congruent parallelograms and an area of a parallelogram is base times height, we have 2 times 30 times 40, 2 times 1200, which ends up being 2,400 square centimeters for that area. Awesome job, you guys. Let's turn the page and keep on going. Awesome. So number 4 is the last problem we're going to be doing. If you'd like to see number 5, you can always check my worked out answers online. So let's read number 4 and track while, and it's a track. Okay, let's track and underline the important information. A rectangular field with 2 semicircles at each of the shorter ends of the field measures 100 yards long and 40 yards wide. So that's just the rectangular part. It's surrounded by a track that's 5 yards wide. Find the area of the field, which includes the 2 semicircles on each of the shorter ends of the rectangle, and find the area of the track. So this sounds like we're kind of doing 2 parts. The first part is to be finding the area of the field. I'd like you to draw a picture of the area of the field and figure out the area of that rectangle and circle, and then we'll start the next part of the video. Okay, let's start the third video.